This is the DAC lab?
Yes.
Okay. First of all, we've got 3 channels hooked up, and I can only see what looks like to be one channel.
Yeah, I got one at a time.
So there's channel 1, channel 2. So I'm going to put on dual so we can see both channels at the same time. Triggering off channel 1 right now. Okay, so what happens is, see how there's kind of signals overlapping?
Yeah.
The reason why is those 2 signals are we've got a nice view there, but see as you switch back and forth, see, you can see this signal. It's kind of, you get the big pulse and then the small pulse, and then now it's kind of the big pulse is going on and off the screen, and so it's not always in the same spot, right? Mm-hmm. So it's although we can trigger off of channel 2, the triggering is not reliable, and it's not reliable in the sense that we don't always trigger in the same place. And we always want to trigger in the same place because, let's say we're trying to set up a test procedure where someone is building something over and over again and they want to verify it's working. You want to be able to set up a test procedure that when you go and test this thing, the signal always looks the same, so that the person going and testing doesn't have to guess, wait, should it look like this or that, right? So in order to do that, what we need to do is trigger off of the lowest frequency signal. So you can see this signal right here, it looks higher frequency than this signal. But they're not really periodic signals. They're not, it's not like a sine wave that repeats. It's not very consistent. This one is long, then short, then a little longer than these, but shorter than this one, right? So I mean, these signals are complex. They're not just simple periodic signals. Okay, if we I'm going to take off channel 2, and I'm going to move the trigger signal over here. So now this trigger signal, relative to this other one, is very simple, right? It's just a pulse that happens every so often. So it's a lot more reliable signal to trigger on. And if we leave that up there and we look at this, right? If we bounce this around, we're always going to get this at the same point, and you can see the trigger is actually happening right here. So, just in case you guys don't remember from AC, what the trigger is it's the point in the signal where the oscilloscope decides to start drawing, right? And so we are now triggering off the signal, and you could trigger on a signal that's rising or falling. And the way you do that on this oscilloscope is you could pull this in or out. So when it's pushed in, it's triggering on a rising edge. And when you pull it out, it's triggering on the falling edge. But it's always triggering at that same point on this rising edge here. Now, that signal it's very consistent, right? It's one high, short, and one long, low, right? So as we switch this around, whenever we go back to channel 2, we always get the same thing: a trigger and then some data, trigger and then some data. Okay. So that's the signal we want to trigger off of, right? And that's why it's over here on the trigger. And then I'm going to go change our trigger source. So this is all the triggering for the oscilloscope. It's all up in here. I'm going to change our trigger source. Instead of line 1 or line 2, I'm going to make it external. So it's triggering off this external signal here. Okay. So before we had it over here, and we triggered off channel 2. Right, and see what the data looks like. You get a little bit of data, a little bit of data. Move it over here, trigger off the external, a little bit of data, a little bit of data. You can just remember, hey, there was a pulse here, a pulse here, a pulse here, right? So
this is still set 7?
This is your chip select line, I think. If you're doing the lab where I think you're at in the lab, pretty sure that's your chip select. Now. So there's our clock. So if you recall, right, there was a pulse here. And the clock is the easier signal to look at. So actually, I kind of want to look at that signal with the clock there. So let's trigger off channel 1. Right. So this is our chip select. Chip select goes low and then goes high. At some point during that chip select, we get our 8 clocks. And same thing again over here. So let's put this back. Trigger off of the external. So we had our chip select goes low, we get our 8 clocks, and during that time we also get data. Okay, so we want to look at the data, right? This is the clock, and this is the data. So to look at the data, what we want to do is position the first bit on the first graticule, and I'm going to change the time base. I guess we need to blow this up a little bit more. But let me back up and explain what I'm doing, right? Instead of just doing it really fast. You know, right, as you change this, it's changing the frequency, right, at which the trace sweeps. Okay, so if and this goes in very defined increments, 5 microseconds per division, 10 microseconds per division, 20 microseconds, right?
Yeah.
You know that from AC.
Yeah.
Okay, if I twist this, it's variable, right? See, it's like, it's not a big step. When you do this one, it's a big step, right? This one, it's smooth, continuous change, right?
Yeah.
The disadvantage of doing this is that we no longer know what the time is. But the advantage of doing that is that we can get this signal to fit on the screen so that we get 1 bit per graticule. Scopes won't draw enough of the trace from where the trigger occurs, so we're just going to have to use the clock to look at the data. The data is valid on the rising edge. So if we look at the clock and we look at the rising edges of the clock, on this first rising edge, we have 1. On the second rising edge, we have 0. So now you can write that down. So first rising edge, we have 1. Here's the second rising edge. There's the second rising edge of the clock, we have 0. On the third rising edge, we have 1.
Okay, wait, the rising edge.
I'm looking at the rising edge of the clock. So if I move this off of here, this is the clock, right? So here's the rising edge, here's the falling edge. Here's the rising edge, here's the falling edge. And so the data is valid on the rising edge. So what I'm doing, I'm having the data overlap the clock so that it's really easy to see. On this rising edge, we're high.
Yeah.
On this rising edge, we're low. So write down high or 1, 0, 1, 0, 0, 0, 1, 1. Okay, I convert that to hexadecimal. Let's do 1248, 1248. It's easier.